Most people connect an inverter to their car battery completely wrong, and it ends up killing their battery within a few weeks. Today, I'm going to show you exactly how to do it the right way, step by step. And stick around, because I'll also cover a safety mistake near the end that most tutorial videos completely ignore, and it's genuinely dangerous. Let's get into it. Welcome to Battery Hacker. I'm Michael. Let's go. So first, what is actually happening here? Your car battery puts out 12 volts of DC power. Your inverter takes that 12-volt DC and converts it into 110 or 220 volts of AC power, the exact same power that comes out of a wall socket at home. That's why inverters are so useful. You're basically carrying a power outlet wherever your car goes. But here's where most people go wrong right from the start. They grab any inverter without checking the wattage. The wattage of your inverter needs to match the total power demand of the devices you want to run. Small stuff like phone chargers, laptops, and LED lights completely fine. But the moment you try running a refrigerator, a power drill, or a microwave, you're asking for trouble with a standard setup. Now here's the part people really don't think about, and this is probably the most expensive mistake you can make. Car batteries are not designed for this. They are built for one thing: a short, sharp burst of power to start your engine. That's it. Run an inverter off a standard car battery for too long, especially with the engine off, and you will drain it fast. Do it repeatedly, and you will permanently shorten that battery's life. So, what's the fix? A deep cycle battery. Deep cycle batteries are built completely differently. They are engineered to deliver steady power over long periods without taking damage. If you plan to use an inverter regularly, a deep cycle battery is not optional. It's necessary. And one more thing to keep in mind before we get into wiring: always watch your battery voltage. As your battery drains, its voltage drops. Most inverters will automatically shut off when voltage falls too low, usually around 10.5 volts. That's a built-in protection feature, because a completely drained starter battery is often a permanently dead battery. Alright, now let's get into the actual connection. This is the part where most DIY setups either work perfectly or go dangerously wrong. So pay attention here. Your inverter has two terminals. Red is positive, black is negative. But the order you connect them matters. Start with the positive side. Take the red cable from the inverter's positive terminal and connect it to the positive terminal on your car battery. But before you finalize that connection, if you are installing a fuse or circuit breaker on the positive cable, do it now. Place the fuse between the battery's positive terminal and the inverter. Once the positive side is done, connect the black negative cable from the inverter to the negative terminal on the battery. That's your basic connection complete, but don't plug anything in just yet. Now let's talk about that fuse, because this is the step people skip, and they really shouldn't. Skipping it is how inverters catch fire. A fuse on the positive cable is your entire system's last line of defense against short circuits and electrical overload. To size it correctly, check your inverter's maximum current draw. If it pulls 100 amps at full load, use a fuse rated for at least 120 amps. Never go lower than the inverter's draw, or you'll keep blowing fuses. And don't go massively oversized either. An oversized fuse defeats the whole purpose of having one. Here's another detail that sounds small but matters more than people realize: cable thickness. For higher wattage inverters, always use the thickest and shortest cables possible. Thin cables and long cable runs create resistance. Resistance creates heat. Heat means energy loss, reduced performance, and in a worst-case scenario, a fire risk. Thick, short cables keep your whole setup efficient and safe. Once everything is wired up, here's what to do before plugging in a single device. Turn the inverter on first and check for an indicator light or display confirming it's working normally. Listen for any unusual sounds. If you feel heat building up immediately or anything seems off, turn it off right away and recheck every connection. Only when everything looks and sounds normal do you start plugging your devices in. And always make sure the combined wattage of all your devices stays within the inverter's rated capacity. Now your inverter is running. Here's how to manage your battery so you don't kill it in the process. The single best thing you can do is keep your engine running while the inverter is in use. When the engine is on, the alternator is continuously recharging your battery, which offsets the power your inverter is drawing. It's like running a tap while the tank refills. As long as the inflow keeps up with the outflow, you're fine. But here's the catch. Your alternator has limits too. If you're running a heavy load, your alternator may not keep up, especially on older vehicles. So even with the engine on, don't push your setup beyond what it can realistically handle. If you need to run the inverter with the engine off for camping, an emergency, or a power cut, watch your battery voltage the whole time. The moment your inverter's low-voltage alarm triggers, usually around 10.5 volts, stop immediately and recharge. Don't ignore that alarm. A starter battery that gets fully drained, even once, can permanently lose a chunk of its capacity. And if you're running a deep cycle battery, make it a rule to never discharge it below 50%. That one habit alone can seriously extend your battery's working life. Now, here's the safety point most videos skip entirely, and this one actually matters. Both inverters and car batteries generate heat during operation. Never run this setup in a closed, poorly ventilated space. Car batteries, especially when charging, can release hydrogen gas, and hydrogen is highly flammable. One spark in an enclosed space with hydrogen buildup is a serious hazard. Always run your setup outdoors or with proper airflow at minimum. It takes 10 seconds to open a window. Don't skip it. When you're done, always switch the inverter off before touching any cables. Then disconnect the negative black cable first and the positive red cable second. That order minimizes the risk of accidental sparking. Store your inverter somewhere dry and cool when it's not in use, and it will last you for years. Quick recap before we wrap up. Match your inverter wattage to your devices. Use a deep cycle battery for anything beyond short-term use. Always install a fuse on the positive cable. Use thick, short cables. Keep the engine running when possible. Never ignore the low-voltage alarm, and always work in a ventilated area. Do all of that and this setup will serve you reliably for a long time. That's it for today on Battery Hacker. If this helped you out, hit the thumbs up, share it with someone who needs it, and subscribe so you don't miss what's coming next. I'll see you in the next one.